So good morning dear students. We are continuing with the same topic, that is application of derivatives and particularly the practical problems on maxima and minima. As I have explained you in the previous 2 or 3 videos regarding the same topic, we are going to continue with the same questions, but today we'll take some complicated questions, okay? Not the complicated one, because we know the concept, then we can do easily. Alright. In front of you, the question is written, that is, find the point on parabola y square equal to 4x which is nearest to the point 2 minus 8. You need to find a point on the parabola y square equal to 4x. Okay, say for example, if this is the parabola y square is equal to 4x. Okay, then you need to find the point on this parabola which is nearest to 2 8. Where the 2 8 can come, this is 1, this is 2, and say for example this is minus 8. So this is the point 2 minus 8. So which is the point on the parabola, so that this point is nearest to that point, whatever point which we will find by the help of the maxima and minima, the concept of maxima and minima. So let us do this question. Okay, you want the nearest distance between this point and the point on the parabola. Then which concept we are going to use? We are going to use the distance formula concept. Okay, if you have x1 y1 x2 y2, then what does the distance formula says? Under root of x2 minus x1 the whole square plus y2 minus y1 the whole square, or under root x1 minus x2 the whole square plus y1 minus y2 the whole square. They both are same at a time. Alright, so let the point on parabola, that means that point on the parabola, be xy. Alright, let that point be xy. What will be the distance formula? D will be under root x minus 2 the whole square plus y minus minus plus 8 the whole square. This is the distance formula between the point on the parabola and that point. Okay, so this is D. Now, as you are given y square equal to 4x, or what will be your y? Will it be 2 root x? Okay, yeah. Now see, this is under root. It's very difficult to differentiate this under root, so do one thing, square both the sides. So d square will be x minus 2 the whole square plus y plus 8 the whole square. Can we consider this d square as fx? So considering this d square as fx. Now this expression have two variables, x and y. So it would be like again a challenging task to differentiate these two variables. So let us replace one variable. We have y equal to 2 root x. So just substitute the value x minus 2 the whole square and 2 root x plus 8 the whole square. Now don't open the brackets, just directly you differentiate. So on differentiate fx, what will be the answer? 2 bracket 2 x minus 2 bracket 1 minus 0, which we can understand, 2 bracket 2 root x plus 8. Now differentiation of this will be, differentiation of 2 root x is 2 into root x is what? 1 upon 2 root x and plus of 0. Differentiation of 8 is what? 0. So 2 bracket x minus 2 plus, you can cancel this 2 with this 2 and you are left with 1 here. Multiply 2 inside, so 4 root x plus 16. Okay, multiply this this under root x is also there, so whole upon root x. Okay, now what you can do, just separate this root x with this 4 root x and 16. So I'm separating it in this particular step. So we have this thing. Now you can cancel this under root with this under root. So I'm rubbing this under root and this under root. Okay, I hope you are understanding. Multiply this 2 inside, 2x minus 4 plus 16 upon root x. This 4 and this 4 you can cancel, and you finally have 2x minus 16 upon under root x. Now you are asked that you need to find the nearest, that means the minimum distance between the point on the parabola and this point, that means the minimum distance. Then that means this is the case of minima. That means on double differentiating, on doing the second derivative test, our value should be positive, then only this will be a minima case. So let us differentiate this. What will be the differentiation of this? This is 2, differentiation of 2x is 2 minus 16 as it is, 1 upon under root x. What is the differentiation of 1 upon under root x? This is minus 1 upon 2 x to the power 3 by 2. Now you differentiate and find. I won't explain you that what is the differentiation of 1 upon under root x. I'm directly telling this is minus 1 upon 2 x to the power 3 upon 2. This minus and minus will become plus, so 2 plus, and you can cancel this 2 with this. So 8 upon x to the power 3 by 2. Alright, so as this is a positive value, on a look-wise it is looking like a positive value, but we need to put the value of x here so that to get confirm that it is of the minima case. Okay, as this you can write, no problem, this is greater than 0, hence this is the case of minima. Now if this is the case of minima, we are going correct. We need to put f dash x is equal to 0 to get the value of x. So put f dash x is equal to 0. So f dash x is equal to 0, which means 2x minus 16 upon root x is equal to 0. 2x is equal to 16 upon root x. Okay, then this 2 with this 8, you take this side, so x root x is equal to 8. This is the power 1, and under root means power half. 1 plus half is what? 3 by 2 is equal to 8. If this power will go that side, so 8 to the power 2 by 3. So x 2 8 is what? 2 cube. 2 cube into 2 by 3. Cube to cube cancel. 2 square is what? 4. So the value of x is what? 4. On putting the value of 4 here, you will get the positive value. So hence it is correct. You got x equal to 4. That means you got the x coordinate. Now let us go ahead and see that what will be the value of y. Okay, this is the possible value of x. That means we won't get any other value. This is x equal to 4. Now what will be the y? So you will be thinking that we'll put y here, x here, and we'll get the value of y. No, you need to put the value here. That means the main equation D, x minus 2 the whole square plus 4y plus 8 the whole square. So if you take that means x equal to 4, then what will be your y? Just wait, see wait, here x is equal to 4, just put here. So y is equal to 2 root 4, which is 2 into plus minus 2. Alright, because when the 4 comes out from the root, it will be plus minus 2. That means we have to accept both the values, because in coordinate geometry we take plus also and negative also. Now which is the final answer? So for y equal to plus 4, just go and check it in the D is equal to that equation, and you put minus 4 also. You put 4 and minus 4 both in that value and just check which is the least value. That means we need the least distance, no? So with which value of y, this should be nearest point, that means the least distance. So that will be your final answer. Okay, let us consider this question. Show that a right circular cylinder which is open at the top and has a given surface area will have the greatest volume of its height is equal to the radius of the base. That means in this question what they are saying, we have the right circular cylinder which is open from the top. Okay, its surface area is given to us. If its surface area is given to us, then we will have the greatest volume, and there its height will be equal to the radius of the base. Okay, so given what all things we have to notice? Given surface area, that means your surface area S is equal to pi r square plus 2 pi r. How this came? This 2 pi r is the curved surface area of that cylinder, and pi r square is the base area. That means this is the circular area, that is why pi r square. We won't consider this pi r square because this is open. Alright, Now this is now their greatest volume, that means we need the volume. What is the volume of the cylinder? This is pi r square h. Okay, so pi r square h. Now see, you can differentiate this equation with respect to r also and with respect to h also, both you will get the answer. But we need to replace one thing from it. Either if you want to differentiate this equation with h, you need to replace this r square, and if you want to differentiate this equation with r, you need to replace h. So how we will replace? With the help of this equation only. Now it is very easy for us to replace the h, because h is only here single and here r square and r, then it is very difficult to find the value of r from here. So what we do is find the value of h from this equation. So s minus pi r square upon 2 pi r equal to h. Put here pi r square bracket s minus pi r square upon 2 pi r. Okay, pi to pi you can cancel, 1 r to r you can cancel. You will get multiply r inside, so sr minus pi r cube. You got v is equal to this. Now differentiate with respect to what? R. So s minus 3 pi r square. Again double differentiate it. You will get 0 minus 6 pi r, that is minus of 6 pi r, which is less than 0. That means this is of a maxima case, and we are going correct because greatest volume means the maximum volume. So now how to get the value of r from here? Put dv dr equal to 0, that is s minus 3 pi r square equal to 0. This will go that side, so s is equal to what? 3 pi r square. Now you need the value of r, then what will be the value of r from here? Your r will be, or else you can do one thing, just to find the value of that h. You have s is equal to 3 pi r square. We need to prove h is equal to r. We don't need to find h or r. Okay, you got s is equal to 3 pi r square. Just put it in this equation. So let us put s is what? 3 pi r square and pi r square plus 2 pi r h. Take pi r square here, so it will become 2 pi r square, because this is 3 times, this is 1 time, so 2 times of pi r square upon 2 to 2, pi to pi, r to 1 r. R is equal to h, hence proved. Okay, please try to understand this question. Show that semi-vertical angle of a cone of the maximum volume of a given slant height is cos inverse 1 upon root 3. Now first understand what is semi-vertical angle. Vertical angle is this one. That means if this is the cone, this is called the vertical angle. It means this V, this is the full vertical, and semi means the half. That means this. So this is called the semi-vertical angle of this cone of maximum volume of a given slant height. The slant height is given to us, is cos inverse 1 upon root 3. We have to prove. Let us consider slant height as L, height as h, radius as r, and the semi-vertical angle as alpha. Okay, so according to this is a right cone. So right cone here, L will be under root of h square plus r square. We can use the application of Pythagoras theorem, or L square will be equal to h square plus r square. So from here take h square here, so L square minus h square is equal to r square. You have volume. We need the volume of cone, which is 1 upon 3 pi r square, because we need to go for the maximum volume. So V is equal to 1 upon 3 pi r square h. Now it is easy to put the value of r square from here. That is why I found r square is equal to L square minus h square. So putting here L square minus h square into h, multiply this h inside, pi, in this pi also, pi L square h minus pi h cube. Now differentiate this with respect to h. So dv dh is equal to 1 upon 3. This will be pi L square only, because differentiation of h is 1. And this is a constant term, so here written as it is, and this will be 3 pi h square. Now again just double differentiate it, just to check whether we are getting for the maximum volume. So double differentiate 1 upon 3, this will be 0 and this will be 6 pi h. So finally you will get minus of 2 pi h, which is less than 0. That means correct. Now put dvdh is equal to 0 to get the value of h, putting this expression equal to 0, and on solving you are getting h square is equal to L square upon 3. Okay, you just pause the video and check or understand. So h square is equal to L square upon 3. You got h is equal to what? Okay, from here what will be your h? This will be L upon root 3. Okay, now you need the height is cos inverse 1 upon 3. So you just go for cos alpha. What will be your cos alpha? If this is the alpha, then in front of alpha this will be your perpendicular and this will be your base. Okay, in front of the theta you always have the perpendicular, no, and this is the base and this is the hypotenuse, which is always the fixed one. So cos alpha says base upon hypotenuse, h upon L. So h upon L, what is your h? L upon under root 3 upon L. L to L you can cancel, 1 upon under root 3. So what will be your alpha? Alpha will be your cos inverse 1 upon 3. So alpha is the semi-vertical angle, hence this question is proved. Okay, let us take this question. It says, show that the rectangle of maximum area that can be inscribed in a circle of the radius r is a square of side under root 2 r. That means this is the rectangle which is inscribed in a circle of maximum area. Okay, of maximum area. Okay, so in this circle you are inscribing a rectangle of maximum area, then this rectangle becomes the square of side root 2 r. That means this acts like a square. If you inscribe a maximum area of a rectangle, then it becomes the square. We need to prove this thing. Okay, so let us consider this line. This line is acting like the diagonal of the rectangle and the radius and the diameter of the circle. Okay, if this is r, then this is also r. That means what will be your AC? This will be the diameter, which is 2r. And as we know that cos theta is what? Base upon hypotenuse. So we can find AD, that is cos theta is equal to AD upon 2r. That means hypotenuse. So AD will be equal to 2r cos theta. And what will be DC? 2r sin theta. Why we are finding this? Because this is the length and this is the breadth. That is why we found. So as we know that area of rectangle is length into breadth. Okay, A. Now I am taking 2 sin theta cos theta, sin 2 theta, 1 2 is here, r into r square. So 2 r square sin 2 theta. Now differentiate it with respect to theta. So 2 r square cos theta into 2 into 2, 4 r square cos theta, cos 2 theta. Now again double differentiate it. You will get 4r square minus of sin 2 theta into 2, or minus of 8r square sin 2 theta, which is less than 0. Now okay, don't write this is less than 0. As we know this is negative and this will be less than 0, but don't write it on a prior. We just find the value of theta, put it, and then you just conclude that this is less than 0. So put dA d theta equal to 0. Okay, that means this is equal to 0. 4r square will go that side and it will be 0. Cos 2 theta equal to 0. Cos 2 theta equal to 0, that is pi by 2. 2 theta is equal to pi by 2. So theta will be pi by 4. Now you just go and check d2a upon d theta square at theta equal to pi by 4. You will get the minus value, which is less than 0. So from there we'll conclude this is for the maximum. This is for the maximum case. So you got theta equal to pi by 4. Now what you do, just find AD. AD will be 2r cos pi by 4 is 1 upon under root 2. On solving you'll get under root 2r. DC also under root 2r. As AD is equal to DC, which means it is a square because your length is equal to breadth. So hence proved like this. Now I'll share you the questions. Okay, I share with you the questions. Okay, you have to do those questions. So please do the practice of this topic. Okay, thank you so much. Have a nice day. Bye bye.